Alright, so in this problem, I have x to the power of 3 plus x is equal to 10. So to solve this, I'm going to first start by subtracting 10 on both sides. So if I subtract 10 on both sides, these two cancel out, and I get x to the power of 3 plus x minus 10 is equal to 0. Now, from here, to actually find all of the solutions for this equation, we have to first start by finding one solution and then use that one solution to find the rest. So how are we going to find that one solution? Well, we're going to simply have to guess. So let's start with x equals 1. When x equals 1, I get 1 to the power of 3 plus 1 minus 10, and this is equal to negative 8, which does not equal 0, which is wrong. Now let's try x equals 2. When x equals 2, I get 2 to the power of 3 plus 2 minus 10. 2 to the power of 3 is 8, 8 plus 2 is 10, 10 minus 10 is 0, so this works. So now that we have one solution of x, we can use this solution to find out the rest of the solutions. And how are we going to do that? Well, if x equals 2, this means that x minus 2 is a factor of our original equation, because if we plug in 2 for x minus 2, that equals 0. This means that I have to divide x minus 2 with x squared plus x minus 10. However, this also means what we can do is we can rewrite x to the power of 3 plus x minus 10 as, well, what's 2 squared? 2 squared is 4, so I get plus 4x, and then because we have plus 4x, what is x? What is 4x plus what is equal to x? Well, 4x minus 3x, or we could also do 5x minus 4x. So we get 5x minus 4x minus 10 is equal to 0. Now, what I'm going to do is I'm going to factor by grouping. So we can group x to the power of 3 plus 5x and negative 4x minus 10. Well, x to the power of 3 plus 5x, the greatest common factor is x. However, this won't work because x squared plus 5, that can be simplified. So what I'm going to do is rewrite this as x to the power of 3 minus 4x plus 5x minus 10 is equal to 0. So now, if I factor by grouping, the greatest common factor from x to the power of 3 minus 4x is x, so I get x times x squared minus 4, plus from 5x minus 10, the greatest common factor is 5. So I get 5 times x minus 2 is equal to 0. Now x squared minus 4, I can rewrite that as x plus 2 times x minus 2. And I have this plus 5 times x minus 2 is equal to 0. Now from here, I can factor out x minus 2, so I get x minus 2 times x plus 2 plus 5 is equal to 0. And this simplifies to x minus 2 times x squared plus 2x plus 5 is equal to 0. Now this gives me two equations. I get x minus 2 is equal to 0, and I get x squared plus 2x plus 5 is equal to 0. Well, for x minus 2 equals 0, I can simply add 2 on both sides, so I get x equals 2. And we already got the solution by guessing at the start. Now for x squared plus 2x plus 5 equals 0, I can use the quadratic formula. So in this case, I get negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c all over 2a. And this is equal to negative 2 plus or minus the square root of 4 minus 20, which is negative 16 over 2. And you can't take the square root of negative numbers, so there's no solution for this, meaning my only solution to this equation is x equals 2. Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 68. So I'm going to first start by rewriting 8 as 2 to the power of 3. So I get 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 68. Now I'm going to rewrite 2 to the power of 3 to the power of x as 2 to the power of x to the power of 3. So I have this plus 2 to the power of x is equal to 68, and I can do this because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. Now from here, I'm going to let 2 to the power of x equal to the variable y. So if I substitute in y for 2 to the power of x, I get y to the power of 3 plus y is equal to 68. And now I can subtract 68 on both sides. So I get y to the power of 3 plus y minus 68 is equal to 0. Now, to actually factor this and find the value of y, I need to first find the factors of 68. So the factors of 68 are 1, 2, 4, 34, and 68. So now 1 wouldn't work because 1 times 68, we can't subtract those two to get y. And 2 wouldn't work either. The only one that would work is 4, because if you divide y minus 4 with y to the power of 3 plus y minus 68, that would be factorable. So now that we know that 4 is a proper factor, for my original equation here, y to the power of 3, I'm going to rewrite this as y to the power of 3 minus 4y squared plus 4y squared minus 16y, which is 4 squared, plus 17y, because negative 16y plus 17y is equal to y, and finally minus 68 at the end is equal to 0. Now I'm going to factor by grouping. So these two are a group, these two are a group, and these two are a group. From y to the power of 3 minus 4y squared, I'm going to factor out y squared because that's the greatest common factor. So I get y squared times y minus 4 plus, from 4y squared minus 16y, I'm going to factor out 4y, so I get 4y times y minus 4. And from 17y minus 68, I'm going to factor out 17, so I get 17 times y minus 4 is equal to 0. Now if I factor out y minus 4, I get y minus 4 times y squared plus 4y plus 17 is equal to 0. And now this gives me two equations. I get y minus 4 is equal to 0, and I get y squared plus 4y plus 17 is equal to 0. So for y minus 4 equals 0, add 4 on both sides, and I get y equals 4. For y squared plus 4y plus 17 equals 0. I can factor this by using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, a is 1, b is 4, and c is 17. So I get y is equal to negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times 17, all over 2a, so 2 times 1. This is equal to negative 4 plus or minus the square root of 16 minus 68 over 2, which is equal to negative 4 plus or minus the square root of negative 52 over 2. and this is equal to negative 4 plus or minus the square root of 52 times the square root of negative 1 over 2. And the square root of 52, this can be simplified to, well, 52, that's 13 times 4, and 4 is 2 times 2, so this can be 2 root 13. So I get y is equal to negative 4 plus or minus 2 root 13 times the square root of negative 1, which is simply equal to I, over 2. Now if I divide both terms by 2, I get y equals negative 4 plus or minus the square root of 13i. Or sorry, negative 2 plus or minus the square root of 13i. So now that we know these values of y, remember how we let 2 to the power of x equal to y, meaning I get 2 to the power of x equals 4, and this is obvious, x equals 2, so that's one solution of x. And I also get 2 to the power of x is equal to negative 2 plus the square root of 13i, and 2 to the power of x is equal to negative 2 minus the square root of 13i. Well, 2 to the power of x, we can't take the power of a positive number and make it equal a negative number. So there's no solutions for these two, and x equals 2 is my only solution to this problem.